everybody. Today we're going to talk about system of three equations. In the past we've done substitution elimination or substitution elimination with two equations, two unknowns. This time I have three equations, three unknowns. Whatever number of unknowns we have, that means different variables, we have to have at least that many equations. So here we've got three x, y, and z, and we've got three equations. Now, I like to label these equations so we can talk about them. I'll go A, B, and C. Okay, and we're going to really do our best to use elimination as much as possible on these. So we want to look at what can I kill easiest, x's, y's, or z's? Well, if we check it out, if I combine A and B, I've got an x and a negative x. So I can add those together. So let's rewrite them over here. X minus 2y plus 3z equals 9er. Negative x plus 3y plus z equals negative 2. So those are just ready that we can combine them. We can just add. So x and negative x, boom, cancels out. That's what we wanted. We get y plus 4z equals 7. Okay, so what do I do with that? Well, I got it down to two unknowns. I need two equations. So I did A and B. Now I'm going to either have to combine AC or BC. Well, I like doing BC because, look, we've got a negative x and a 2x, almost ready to cancel. So let's rewrite those. So we get negative x plus 3y plus z equals negative 2, and 2x minus 5y plus 5z equals 17. All right. And I should separate this. We did that one first. Now, almost ready to cancel, except I need that to be a negative 2. So let's multiply everything in this equation by 2. And I'll rewrite it here. That gives me negative 2x plus 6y plus 2z equals negative 4. Now we can combine those, and I get y plus 7z equals 13. So now look, one equation, two equations. Y's and z's, y's and z's. I need to cancel out the same variable twice. I canceled out x's both times so I can get the same two variables left over. So let's rewrite them over here. Y plus 4z equals 7, and y plus 7z equals 13. Now, this has worked out really nicely. We've got a y over a y. So I just need one of them to be negative. So let's multiply the top one by negative 1. That gives us negative y minus 4z equals negative 7. Combine them. I get 3z equals 6. Divide by 3. Z equals 2. You all see what we did there? Z equals 2. Well, what can I do with that? Well, I can plug that into one of these two equations to find y. I kind of like this one better. And it doesn't matter which one you plug it into. So that's z is going in here. So I get y plus 4 times 2 is 8 equals 7. Subtract the 8. Y equals negative 1. Now, I have z is 2, y is negative 1. Let's plug that back into one of the original ones to find the x. Well, equation A has an x that's positive and by itself, so let's plug it in. Hopefully we can see if I put it here. So we get x minus 2 times y, which was negative 1, plus 3 times 2, because z was 2, equals 9er. So it gives me x, negative 2 times negative 1 is plus 2, plus 6 equals 9. That's 8. Subtract 8 over. X, can we still see, equals 1. Now check this out. We haven't done this before. It's an ordered triple, not an ordered pair. X comes first. 1, negative 1, because that's y. 2. Can we see that? Boom. And that's how you do this. Okay? So the key is pick which variable you're going to get rid of twice. So we got rid of the x's twice to get down to y's and z's. I could have gone with another. Z's I could have done. Could have gone B and A and multiplied this by negative 3 to get rid of this one. Negative 5 to get rid of that one. Okay? These are a little tricky, but step by step, hopefully you can be neat and organized. I like using my colors. Any questions, hit me up. These are pretty fun. They're just a big puzzle. All right? And remember, stay safe.